Hello, this video is a series of videos to help you program your various assignments. To begin with, you should pull up the assignment itself and become familiar with what's being asked of you. So we're going to use the example assignment to use for this video. When you pull it up, it has some beginning information here just to help you out that when you're going to run this in the lab, you need to bring your safety glasses, this document, which is the assignment printed out, and then a printout of your CNC program itself, plus a setup sheet of how you're setting up the stock, what tools, what fixture, etc. Also penciled or pen or penciled to make notes, etc. All right, so we're past that initial, and that'll happen with every program will have that same beginning. As we look at the actual assignment, you'll see the general size is 3 inches by 3 inches, and then and some lines in here, and you're like, what's all that about? Well, you actually have to get down to the nuts and bolts down here, which says that the material is waxed. It's 3 inches by 3 inches by 1 inch thick. We're going to use fixture offset G55. That's important for the setup person on the machine. That I'm reminding you to use a tool length compensation, which is G code G50 or G43. And then here it is. The goal of this program is to scribe the above lines in the top of stock. Scribe these lines on the top of the stock. I tell you what tool to use, which is an 1/8 inch ball nose end mill. I tell you what tool number it is, which is tool number 1. And then I also tell you the depth of cut for the scribes, so 10 thousandths. I also tell you, in this case, the spindle speed I want, the entry feed rate, and the cutting feed rate I want you to use. All right, so all that is pretty critical information. Prior to this video, you've been looking through a bunch of stuff, and your head's probably swimming with how to even begin this. Well, the print tells you the X and Y locations, right? You're looking down in the XY plane, it's telling you the XY locations. Pretty straightforward. We also talked about rapid planes up here. Rapid planes. You had a video on it, and you also have a handout. Okay? So I'm going to double click on this handout. If you look at this handout, I'm stepping you through step by step what it means. Step 1, 2, 3, 4. Here it is. Step 1, 2, 3, 4, 5, 6, 7, 8, 9. Literally, you have to know where the rapid plane is. And the rapid plane is above the top of stock. It's also above all the other clamping and fixturing and nuts and bolts and anything else you can have, because the rapid plane is where you move your tool rapidly to the new position in preparation for entering stock. It's also where you exit out of stock. Okay? So you have to establish the rapid plane. In this class, unless told otherwise, it will always be Z.100. That means 100 thousandths above the top of stock. From the top of stock up here, 100 thousandths. Okay, so that's critical to know, is where's the rapid plane. Also, you have to know the depth of cut. In this example, I just drew the tool path below the top of stock. I didn't give you a value, but that's something you need to know. So I'm going to just minimize this and go back to the assignment. The assignment says that the depth of cut will be negative 10 thousandths. So you've just now figured out the two Z values that you need. You need to know the rapid plane, which is Z.100, 100 thousandths above top of stock, and you also know the maximum depth of cut of your tool path will be negative 10 thousandths. All right. So if we pull this together, we know that this location, this point, is X.5 and Y 0.75. We also know that the depth of cut is Z in negative 10 thousandths. Okay, well that's a big start right there. So going back to my rapid plane, I know that I need to change tools to tool 1, because I call it out right here. And then I need to wrap it in the XY plane to the XY position above my point. So my point is down here at X.5 and Y 0.75 and Z negative 0.01, but I need to wrap it to the XY position first. Then I will wrap it down to the rapid plane, which is Z.1. Okay? So up here, if you look at this program I wrote for you, I call out rapid move to X.5 and Y 0.75. My next line is a rapid down to within 100 thousandths of the top of stocks to my rapid plane. That's what point 2 is. Then if you notice at point 3, I'm going to go to a GO1, which is a feed rate, a cutting rate for the mill, and I tell it the feed rate, and I tell it X, Y, Z position. In this case, X and Y have not changed. I'm simply plunging down from here, down into stock, to a final destination of Z minus 0.010. So that's that first move right there. I change tools, I wrap it up in the above all the whole part and all the setup, then I wrap it down to within 100 thousandths of the stock. I feed into that XY position, and then I change and go to a cut mode and cut along that line. So that's what this line is. I change to a faster cutting feed rate, and I go to the next position. Okay? Just to give you some idea. Then when I'm at the end of that position, I want to wrap it up to the rapid positioning plane. So I go back to G00, I wrap it up to the rapid position, the rapid plane. Then I wrap it to my new position, which in this case would be up, wrap it to the new XY plane position, which is X, in this case 2.2. And then I want to feed down into my stock. So I go from a rapid, and then I want to feed down to my, when I enter into stock, and I'm down in the stock, and then I want to change my feed rate to a cutting feed rate and go to my next position, sliding over to here. And then when I'm done with that, I want to change back to rapid mode and back up to the rapid plane. So basically, that is the sequence of events for everything you're going to be programming in this class. You need to know your rapid plane, you need to know your depth of cut, and then you need to know what sequence of events, which is G0s, G01s, feed rates for entry, feed rates for cutting, and it just repeats. Okay? Some more items you'll need to understand is, are you doing any side cutting? Because as you look at this part, you have to figure out how to hold it. In this case, I don't cut the outside, and I do cut along the top. So in this case, I could simply decide to use a vise, and I could draw in a vise right here, and a vise right here, and I could indicate that that edge of this vise is 0, 0 because it corresponds to the 0, 0 here. And I can indicate a side stop over here and indicate on that that is 0. And that's my X and Y. And then, of course, for this example, since I'm using Z, the depth of cut of 10 thousandths from the top of stock, I might as well use Z top of stock. So if I go back to my rapid plane, you can see here I use that the top of stock is my Z0. For this project, I give you an example setup sheet, so let's go look at that now. Example setup sheet. As you look at this, you can see that I call out what it is. It's the example program. I tell the operator what the material and size is. I ask the operator to set up a specific tool or tools needed for this. In this case, T1, what it is, and then how many flutes. And then I tell the operator what fixture offset I'm using, in this case, G55. Then I give them a visual for how this works. So here's my stock, okay, 3x3 stock, and here's the visor clamp, and I indicate that this edge is the X0 and that this edge is Y0. And I also indicate that the top of stock is Z0. So those are the three things you need to know for X, Y, Z. I also include more information because I do cut across the top, and I don't want my side stop to be higher than the top of stock, so I indicate that I want a minimum of a 1/4 inch gap here so there's no chance of me hitting anything. And also that I want the vise to clamp on a minimum of 150 thousandths because it is wax. If you pinch too or clamp on it too little, you could crush it. But I also don't want the vise to clamp onto so much material that it gets close to going to the top of stock or even above the top of stock. So I indicate more information here. Not too much, but enough so the operator knows where they stand. So this is very important, and you can certainly use this setup sheet for probably a majority of the programs you'll be doing in this class.